On December 13, 1972, Cernan and Smith performed the last moonwalk of a series of 3 moonwalks. They spent 71 hours on the lunar surface as a part of the Apollo 17 program. This was the last time ever humans walked on the moon. Now, almost 50 years have passed, but humans are yet to set foot on the moon again. But it's all going to change soon with NASA's Artemis mission. NASA is going back to the moon for scientific discovery, economic benefits, and to inspire a new generation of explorers, the Artemis generation. This will also maintain America's leadership in space exploration. The Artemis mission will enable a growing lunar economy by fueling new industry, supporting job growth, and furthering the demand for skilled workforce. Earth's moon is a 4.5 billion-year-old rock preserved by the cold vacuum of space. The lunar samples returned during the Apollo program dramatically changed our view of the solar system. Future samples from Artemis mission will continue to advance our knowledge of the history and formation of our solar system, including Earth and the Moon. Permanently shadowed regions of the Moon, including craters at the South Pole, are rich in frozen water. Finding it on the Moon, extracting it and converting it means water for drinking, oxygen for breathing, and rocket fuel to power mission farther into the solar system. Finding and using resources in space make exploration more affordable when we do not have to send everything from Earth. This will also help NASA get ready for the next giant leap, human exploration of Mars. Two principal elements of the Artemis program are the Orion spacecraft and the Space Launch System or SLS. NASA's SLS is a super heavy lift rocket that offers more payload mass, volume, and departure energy than any other single rocket. It is powered by a twin 5-segment solid rocket booster in addition to the 4 RS-25 liquid propellant engines. The Artemis program is organized around a series of SLS missions. These space missions will increase in complexity and are scheduled to occur at an interval of a year or more. NASA and its partners have planned Artemis I through Artemis V missions. Later Artemis missions have also been proposed. Artemis I was the successful Uncrewed test of the SLS and Orion. Launched on 16 November 2022 from the Kennedy Space Center, Florida, NASA's mega moon rocket, the SLS, roared into the night sky and sent the Orion spacecraft on a 1.4 million mile journey beyond the moon and back. The SLS rocket produced 8.8 million pounds of thrust during liftoff, which lifted the vehicle weighing nearly 6 million pounds to orbit. After jettisoning the booster, service module panels, and launch abort system, the core stage engine shut down and the core stage gate separate from the spacecraft. The interim cryogenic propulsion system or ICPS lies just below the Orion capsules. As the spacecraft makes an orbit of Earth, it deployed its solar array, and ICPS gave Orion a big push that was needed to leave Earth's orbit and travel towards the Moon. From there on, Orion was on its own. Orion serves as the exploration vehicle that carries the crew to space, provides emergency abort capabilities, sustains the crew during the space travel, and provides safe re-entry from deep space return velocities. The outbound trip to the Moon took several days, during which the engineers evaluated the spacecraft system and corrected its trajectory as needed. Orion flew about 100 km above the surface of the Moon and then used the Moon's gravitational force to propel the Orion into a new deep retrograde. The spacecraft stayed in that orbit for approximately 6 days to collect data and allow mission controllers to assess the performance of the spacecraft. For its return trip to Earth, Orion did another close flyby of the Moon that took it within about 100 kilometers of the Moon's surface. The spacecraft used another precisely timed engine, firing in conjunction with the Moon's gravity, that accelerated it back towards Earth. This maneuver set the spacecraft on a trajectory back towards the Earth. Prior to entering the Earth's atmosphere, the crew module separated from its service module. On 11 December 2022, Orion splashed down in the Pacific Ocean west of Baja California, completing its 25-day mission beyond the Moon. During re-entry, Orion endured temperature about half as hot as the surface of the Sun. Within about 20 minutes, Orion slowed from nearly 25,000 miles per hour to about 20 miles per hour for its parachute-assisted splashdown. The splashdown occurred 50 years to the day since NASA's Apollo 17 moon landing. When Orion was nearing Earth, it attempted the first skip entry for a human spacecraft, a maneuver designed to pinpoint its landing spot in the Pacific Ocean. During this skip entry, Orion dipped into the upper part of Earth's atmosphere and used that atmosphere, along with the lift of the capsule, to skip back out of the atmosphere and then re-enter for a final descent under parachutes and splashdown. Skip entry can extend Orion range by 2 to 4 times compared to direct entry. The skip entry also allowed astronauts to experience lower gravitational force during the entry. The initial SLS flight housed CubeSats in the Orion stage adapter, a ring that binds the interim cryogenic propulsion stage to Orion's spacecraft adapter. CubeSats are a class of nanosatellite that use a standard size and form factor. Orion's stage adapter on Artemis I carried a fleet of 10 6U CubeSats to deep space destination, where they were deployed to gather data valuable for human return to Moon and eventual exploration of Mars. Among all the CubeSat flying, there are two that are of particular interest. First is BioSentinel, which includes a biosensor to detect and measure the impact of space radiation on living organisms over long-duration mission. The second is COSP, which is a CubeSat designed to study solar particles, will carry 3 instruments and orbit the Sun interplanetary space, measuring incoming radiation hours before it reaches Earth as a space weather station. The Artemis II mission, scheduled for launch in 2025, will be a crewed lunar flyby. This 10-day flight aims to test the SLS rocket and Orion spacecraft for the first time with astronauts. 4 astronauts have been selected for NASA's Artemis II mission: Commander Red Wiseman, pilot Victor Glover, and mission specialist Christina Koch from NASA, along with mission specialist Jeremy Hansen. The mission will launch from NASA's Kennedy Space Center in Florida on the SLS rocket. The initial launch will be similar to Artemis I, as SLS will loft Orion into the space and then jettisons the booster, service module panels, and launch abort system before the core stage engines shut down and the core stage separates from the upper stage and the spacecraft. With crew aboard this mission, the upper stage and Orion will then orbit Earth twice to ensure Orion's system are working as expected. After they burn to enter high Earth orbit, Orion will separate from the ICPS. The crew will use Orion's onboard camera and the view from the spacecraft window to line up with the ICPS as they approach and back away from the stage to assess Orion's handling qualities. This demonstration will provide performance data and operational experience that cannot be readily gained on the ground. After completing checkout procedures, Orion will perform the next propulsion move, called the Translunar Injection Burn. The TLI burn will send crew on an outbound trip of about 4 days and around the backside of the Moon, where they will ultimately create a figure 8 extending over 230,000 miles from Earth before Orion returns home. Before astronauts launch an Artemis mission to the Moon, they will suit up in a bright orange spacesuit called the Orion Crew Survivable System. This spacesuit, or inside NASA's Orion spacecraft, is designed for a custom fit and equipped with technology features to help protect astronauts on launch day in emergency situations throughout high-risk part of mission near the Moon and during high-speed return to Earth. Many missions, including Artemis, require 2 spacesuits, one like the OCSS worn inside spacecraft and another worn outside the spacecraft during spacewalk that function as the self-contained personal spaceship. These are called Exploration Extravehicular Mobility Unit. Following Artemis II, Orion and a crew of 4 will once again travel to the moon, making history with the first woman and the next man to walk on its surface. Beginning with Artemis III, mission will focus on humanity's first return to the lunar surface in more than 50 years. Traveling towards the moon, the crew will perform corrective engine burns to intercept the moon's gravitational field. At the right time and location, Orion will perform a series of 2 engine burns to place the spacecraft in a near rectilinear hollow orbit (NRHO) around the moon. A hollow orbit is a periodic 3-dimensional orbit associated with one of the N1, L2 or L3 Lagrange points. Although a Lagrange point is just a point in empty space, its peculiar characteristics is that it can be orbited by a hollow orbit. These result from an interaction between the gravitational pull of the 2 planetary bodies and the centrifugal force on the spacecraft. A near rectilinear hollow orbit is a hollow orbit that passes close to the smaller of the 2 bodies, in this case the Moon, and has nearly stable behavior. From hundreds of potential orbits, NASA selected NRHO to achieve the long-term goal of the Artemis mission. NRHO will provide near constant communication with Earth and access to sites all over the Moon. NASA has selected SpaceX to provide the human landing system that will transport Artemis III astronaut from Orion in lunar orbit to the surface of the Moon and back. After a series of tests, SpaceX will fly at least one Uncrewed demo mission that land Starship on the lunar surface. Before the crew launch, SpaceX will launch the Uncrewed Starship human landing system to NRHO, where it will await the Artemis III crew. When both spacecraft have arrived in NRHO, Orion will dock with the Starship human landing system in preparation for the first lunar surface expedition of the 21st century. Once the crew and their supplies are ready, 2 astronauts will board Starship and 2 will remain in Orion. Orion will undock and back away from Starship to remain in NRHO for roughly 1 orbit around the Moon, lasting about 6.5 days. This will match the length of the surface expedition, so as Orion completes its orbit, the 2-person surface crew will finish their work on the surface in time to launch back to meet the spacecraft. NASA has identified 13 potential regions near the lunar south pole. Each region contains multiple potential landing sites for Artemis III. All regions are considered scientifically significant because of their proximity to the lunar south pole, which is an area that contains permanently shadowed region rich in water, ice, and other resources. During their time on the Moon, the astronaut will do scientific work inside the Starship and conduct a series of moonwalks, exiting Starship to explore the surface. During this, the astronaut will take pictures, videos, survey geology, retrieve samples, and collect other data to meet specific scientific objectives. When their surface expedition is complete, the 2 astronauts will lift off the surface of the Moon and head back to NRHO in a Starship to reunite with their crewmate in Orion. When they reach the optimal NRHO departure point with all 4 astronauts back in Orion, they will undock and ignite Orion engine, slinging the spacecraft past the Moon and allowing it to coast toward Earth. Artemis III will be one of the most complex undertakings of engineering and human ingenuity in the history of deep space exploration to date. Following the Artemis III mission, astronauts on Artemis IV will live and work in humanity's first lunar space station, the Gateway. Built through international and commercial partnership, Gateway will include docking ports for various visiting spacecraft as well as space for the crew to live, work, and prepare for lunar surface mission. Gateway's oval-shaped orbit passes over both the north and south pole of the Moon, providing unparalleled opportunity for scientific research and access to the lunar surface. Once in its orbit around the Moon, Gateway system will prepare for the arrival of a second habitation element with the Artemis IV crew. The International Habitation Module, or IHAB, provided by the European Space Agency will expand Gateway's capabilities. Stepping on the Moon is one part of the mission. Exploring the Moon surface is the second part. NASA has newly created the EVA Extravehicular Activity and HSM Human Surface Mobility Program. The main goal of this program is to provide safe, reliable and effective extravehicular activity and human surface mobility capabilities that allow astronauts to survive and work outside the confines of a base. The EVA and HSM program consists of several key elements including ISS EVA, Exploration EVA, the Lunar Terrain Vehicle and Pressurized Crewed Rover System. The Lunar Terrain Vehicle will be with advanced power management, autonomous driving, state-of-the-art communication and navigation system, along with other extreme environment technology that will provide the ability to collect and conduct science while keeping astronaut and the vehicle safe and ready for its next mission. Another such rover is the Pressurized Rover, which will greatly expand our ability to explore, live and work on the lunar surface. Having a pressurized volume to live in, astronauts can live and work in the vehicle to conduct exploration and scientific activities without the hindrance of a spacesuit. The Moon may be the first exotic destination astronauts visit next, but the EVA and HSM program will help the agency methodically plot a course to Mars and beyond.